Hello guys, so this is our last topic on molecular biology. Yan, DNA fingerprinting or DNA profiling. Let's begin. So it starts in the rape case of Linda Mann and Dawn Ashworth. Yan. So ito si Linda Mann, guys. She is 15 years old. And while she was walking home on November 21, 1983, she was raped and strangled. Yan. The next day, nahanap yung katawan niya. This was Linda Mann. And next was Dawn Ashworth. She was just 13 years old. At sabi ng nanay niya, umuwi ka ng 9:30 p.m. But no Ashworth, no Dawn came home at 9:30 p.m. And 2 days later, she was found dead, beaten, and was savagely raped. Pareho sila na-rape, tapos pinatay. Yan. And they had a prime suspect naman of the case. Okay, it was Richard Buckland, only 17 years old. And he had learning difficulty. So, ibig sabihin, meron siyang mga challenges, so, ibig sabihin, kumbaga, kung i-interviewin siya ng British authority, he could not defend himself properly, di ba? Kasi may learning difficulty siya. He was the one who disclosed the body of Dawn in a path sa isang daanan. Siya ang nakakita ng katawan ni Dawn. And he was arrested by the British authorities. So, poor guy, di ba? He's 17 years old. So, he was the prime suspect. Okay, suspect lang naman. Pero, nakulong siya. Okay? And then, si Linda and Dawn, nakakahanap sila ng blood type A, blood in their genital area, and seminal specimen. And tinago yun ng mga forensic or criminal investigators. So, guys, yun. Yan. At malalaman natin kung sino pumatay at nag-rape sa kanila in a while. Pero malaki ang contribution doon ni Dr. Alec Jeffrey. So in 1985, guys, he discovered DNA fingerprinting. So he was observing a series of X-ray films. Yan, itong mga X-ray film na to are DNAs. Yan, and they're coming from only one, they're coming from different members of the family. So, ito yung DNA X-ray film ni mama, ni papa, ng anak, ng pinsan, and all. Okay. And he notices, guys, that each person has a unique DNA fingerprint. Just like each one of us, our fingerprint is unique. Yan. There's a portion on our DNA that is also unique, that is only found in us, kay Anjali lang, okay? It's her DNA fingerprint. It is a unique sequence in the non-coding region, okay? So, itong fingerprint na to, nahanap lang sa non-coding region or introns, di ba? And are they also called as mini satellites or microsatellites? So, in these satellites, these are unique sequence na nahahanap lang kay Alec, nahahanap lang kay Joshua, nahahanap lang kay Junjun. Yan. So, ayun guys. So, it's unique just like a fingerprint. Okay? So, ma'am, hindi ba unique ang DNA? Talaga? Hindi ba guys, do sa review, most of the human genome is 99% similar, okay? Yung mga genes natin, okay, it's 99% similar, okay? What differs is our alleles and phenotypes. Kaya iba-iba, kaya may blonde, may black ang hair, kasi nag-iba lang yung allele ng DNA, okay? But it's still the same. Yung gene natin, kunyari, like eye gene, yan. So, lahat tayo may eye gene, pero iba lang yung eye color gene, okay? So, we have a 0.1% variation. So yun ang nahanap ni Alec Jeffrey, okay? So that satellite is a slight variation, that's the 0.1%, okay? That would allow us to identify individuals, okay? So in a certain loci, on a certain segment or a certain portion of your DNA, may mga repeating nucleotides, okay? So just like this one, ACG, AGC, yan. So ACG, kung susundan mo to, AGC, yan. So kunyari, ito yung kay Angeli, yan. So sa ibang lokay ng ibang tao, iba naman yung tandem niya, AGT, AGG, AGT, AGG. Yan. And AGGT, ACA, GGT, AC. Yan. Anyway, so there's a in the non-coding region sa mga intron natin, guys, is there are repeating tandems. Yan. So, yun ang i-discuss natin kasi yun yung fingerprint natin. Okay? So, ang madalas na ginagamit, guys, are your short tandem repeats or your STR, okay? So, your Alec Jeffries, guys, targeted these STRs, this repeating sequence on a DNA, the repeating sequence of DNA in number of loci which differ for person to person. I'll give you an example, okay? So we have 3 men. Sabihin natin, iba't ibang lalaki. Yan, hindi alam kung sinong tatay ng anak. Ganyan. So notice in a loci, ito, in a certain portion, magkakaibang beses nag-repeat ang itong tandems. Okay? In this loci, sa man 1, 5 beses na in this segment, yan, 5 beses na ulit itong CTA sa lalaking ito. Okay? Sa man 2, 6 na beses na repeat itong, so this makes them unique, okay? But guys, just to, take note lang that usually in forensic science, we assess at least 13 short tandem repeats, okay, in 13 segments or 13 loci. Ibig sabihin, yan, hindi lang isang loci ang i-assess natin, okay? So example, when there is crime, ganyan. So dapat maximum of the 13 loci, magkahawig talaga yung short tandem repeats nila, okay? Kung dalawa, tatlo, isa lang nakapareho na loci, out of 13, dalawa lang yung may kapareho, parehong 5 repeats, parehong 6 repeats, pero the rest magkakaiba na. So that's not the person that we are targeting. Okay? So dapat, out of 13, dapat pare-pareho sila ng short tandem repeats. So ibig sabihin, magkakaibang mga tao to, guys, kasi in this loci, CTA was only repeated 5, then 6, then 7. Okay? Dito pa, guys, magkakaiba pa sila. Anyway, hindi yan dapat natin. Pero, ganyan. Example pa, guys. So, we have Jojo, Eza, and Junjun. Okay? Jojo, guys, IGAT, in this loci, it was repeated 7 times. For Eza, it was only repeated 4 times. And for Junjun, it was repeated 12 times. Yan. So, magkakaiba sila. It's unique. Okay? Dito sa second loci, AG80 was repeated 6 times. AG80 was repeated 19 for Eza and 14 naman kay Junjun. Yan. So, it makes them unique. Okay? So, yan ang DNA fingerprint niya. Sabi niya, Bozeman Science, yan. Screenshot ko sa YouTube niya. You could watch his video on DNA fingerprinting. Yung genes natin, guys, magkakapareho. Okay? Same. So, sa blondie, same. Sa red hair, same. Sa person with that is brunette, same yung genes natin. Okay? But in the areas of the non-coding regions, mayroong magkakaiba, okay? Magkakaiba ng length ng short tandem repeats, okay? Kay blonde 10, kay red 14, kay red head, kay brunette 5. Yan. So, ito yung mga short tandem repeats. Magkakaiba, okay? So, if it's the same person, yan, So, kunyari crime scene, yan, si Blondie yung may krimen. So, dapat pareho sila in this loci, 10 rin yung nasa crime scene, 12 rin yung nasa crime scene on the second loci. Okay? So, I hope you're getting it. So, ginupit natin. Ayan, ginupit natin. Tinira natin guys yung mga short tandem repeats. Yan. So, it could look like this. Okay? So, we could cut them using restriction enzymes. Yan. So, if you want to multiply them, amplify them, we could use PCR. And we could separate the fragments and visualize them using gel electrophoresis. Diba? Pinag-aralan natin yung mga yan. So, this could be the flow of the steps on DNA fingerprinting. Okay? Pero I'm reading, guys, instead of restriction enzyme, cutting it with restriction enzyme, we could just buy a primer. Okay? Bili ka na lang ng primer na that could detect the repeating tandem. Okay? So, iba, hindi na kailangan gupitin ng restriction enzyme. Just replace the primer in your PCR. Yan. So, pag ginapit mo, pag in-isolate mo, so yung challenge is you have to isolate the short tandem repeats. Okay? So this was repeated 10 times, this was repeated 14 times, this was repeated 5 times, and so on. Okay? So guys, kung i-visualize na natin gamit ang electrophoresis, example, this is a blood from a crime scene. Sino yung may may kahawig ng blood sa crime scene? 1, 2, 3, 4, 5, 6. So 6 na loci ito. So sino ang may kapareho niya? Yan. So kayo na sumagot. Yan, di ba? So ito bang blondie, redhead, or brunette? Yan. Sino ang may pinakakahawig niya na STR. Okay? So, ma'am, why STR? Meron rin kaming nababasa na VNTR sa module, variable number tandem repeats. So, right now, guys, short tandem repeats is more reliable for DNA fingerprinting because of its high degree of polymorphism. Yan. It changes. Yan. It changes polymorphism. Di ba? More form. It changes in form. It has many forms. And most useful for DNA analysis. It changes, it's unique. So therefore, since it's very unique, yan, it could really identify Angeli, okay? So it's much shorter. STR is much shorter than VNTR. VNTR means variable number of tandem repeats. Kung 2 to 6 lang ang STR na paulit-ulit, itong VNTR, variable number, medyo paiba-iba yung repeating number. Yung parang una kong image na napakita yung TAGG, yan, CG, TAGG, CG. Ayan, parang magkakaiba yung sizes ng mga repeating tandems. Okay, so right now, it's more reliable to do short tandem repeats. Okay, so it's more accurate. It is shorter, so it's easier to handle. Naulit pala. It has high power of discrimination. You could easily discriminate, hindi stereotyping You could easily distinguish a person from another, okay, through STRs. And even though the samples are already degraded, you could still use it. Okay, yan. So, yun yung advantage ng STR. Siguro, kumbaga, it could withstand degradation. Yan. It could still be detected. So, you could, if you want to assess kung sino yung skeleton na yun, may na-exhume kayong bangkay. Yan. You want to identify who is this. Yan. So, you could still use the specimen. Okay? So, the disadvantage is, since it's highly polymorphic, it has many forms, it's prone to mutation. And guys, so you could not distinguish the twins. Okay, so twins, if they are identical, they only came from one ova. Guys, pareho sila ng short tandem repeats. Okay, so nakita kong issue dito, guys. What if, kunyari, yung lalaki may ka-twin siya. Okay, tapos may nanay na he's finding the he wants to get child support from the dad. Okay, so nung kumuha siya ng DNA from the dad, yan, pareho nga nung anak niya, yan, 50% of the DNA of the kid is the same with the child. Pero however, yan, paano pang may twin yung allegedly na dad, yan. So, pareho sila ng DNA. Okay, so sino ba talaga yung tatay, yung isang twin or the other twin? Because they have identical short tandem repeats. And so this is your VNTR. It's also called as mini satellite, microsatellite ang tandem repeats. Okay? Di ba ang satellite? Yan. So parang segment. Ganon. Yan. So example dito, it's repeated 8 times. It repeated 20 times. This one, repeated 4 times. So medyo may pagkahaba. Itong variable na number tandem repeats. What are the uses of DNA fingerprinting for forensic science? Okay. So guys, it does, though your DNA is found in a crime scene, it's not necessarily that you are the suspect or the killer, di ba? Minsan naiiwan lang talaga yung DNA natin doon, di ba? How about your DNA fingerprinting? So it does not prove they committed the crime, but their DNA was there. Okay? But guys, if your DNA, kunyari it was raped and was found in the semen inside the genital of the victim, edi sure na yon, okay? But kung nakakalat lang sa crime scene, yan, pwedeng lang yon, contaminant, okay? For medical problems, if in paternity issues, kung sino yung tatay, inheritance, kung sino ba yung mga anak talaga, and immigration, yan. So if do they really have family, ay ganito they really have family relatives, ka-relative ba talaga nila yung pupuntahan nila, ganyan. Or if not, yan, illegal immigrant, yan, so paalisin, i-deport. What else? Victim identification in mass disasters. Yan, example, kunyari may landslide, yan, nagdaganan, walang na-identify. And so you could use DNA. So the family members could get a swab. Yan. Tapos, dapat kahawig yung STR sa family members. Yan. And in conservation biology and evolutionary studies. So if you want to assess if the animals are in the same species, or mag-anak ba yung animal, ganyan. They are the same phylum, same genera, and so on. And you could use DNA fingerprinting. So guys, take note lang, DNA fingerprinting, fingerprinting could be also already replaced by DNA sequencing. Okay? And guys, ang isa daw na disadvantage na nangyayari na dito sa DNA fingerprinting or DNA profiling na yung FBI in the US, guys, kumukuha na sila ng DNA ng bawat tao. Okay? So, careful. Yung parang lang yun. Kumbaga, so pag nahanap na yung DNA mo dun sa lugar na yun, tapos may kopya sila, yan. They could pwede ka nilang gawing suspect, something like that, because they already have a copy of your DNA. Hanapin na lang nila sa database. Tapos, ayun, nag-match kay Angelina Rana, tawagin natin siya for investigation. Yan. It could be advantages and disadvantages. Okay. So, example, yan. Gawa na naman to ni Alec Jeffries. Okay, in 2012, guys, in a car park in UK city of Leicester, guys, they found a skeleton. Yan, dito sa car park na to. And a number of genetic tests were carried. So they performed genetic tests on the teeth, bone, and mitochondrial DNA. And so they performed short tandem repeat analysis of the Y chromosome. And guys, through that DNA fingerprinting, they found out. So perhaps they compared it to sa mga naiwang panggamit ni King Richard III. Yan. So sa kanya pala yung skeleton, diba? So napakalaga nun sa history ng UK. So he died in the battle in 1485. Yan. So biglang nahanap yung katawan niya na nasa ilalim ng car park, 'di ba? So it was identified that it was King Richard III all along, 'di ba? So the body was really old, for 1485 pa. Galing, 'di ba? So here another example. So there was a fatality. So namatay yung soldier, guys, and kinuha yung short tandem repeats niya and extract. Yan. So extract muna ha. Dapat ito pala yung number 1. Yan, you have to extract the short tandem repeats, then yon, restriction enzyme. So, depending on the sample source, okay? So, pwede sa follicle ng hair, pwede sa semen, pwede sa WBCs. So, ito yung electrophoresis results ng soldier, okay? And find. So, dapat 50% ng short tandem repeats ng soldier nasa parent A, and 50% ng SDR niya ay nasa tatay. Okay? So, aling parents? Parents AB, parents CT, parents EF, and parents GH. Kaya, ang most probably parent ni soldier. Diba? So, they have to do it. So, ito ba? Yan. So, dapat 50% nito sa nanay, 50 nito sa tatay. Itong parents B, yan, may kamatch naman, dalawa. So, 4, 1, 2, 3, 4, 5. So, 4 out of 5, kamatch yung parent B. Sa parent A, 1, 2, 3. 3 out of 5. Yan. So, mataas na rin. Yan. Kaso, tingnan natin itong parent C and D. So, letter D, match yun. D, match rin yun. D, yan, 4 out of 5. Dito C, kamatch rin. C, kamatch din. So, mas marami siyang kamatch sa parent C and D. Okay, so the soldier parents could be C and D. Parent E, yan. F, letter E, 1, 2. 2 out of 5. 1, 2, 3, 4. Yan. So, mas maraming kamatch itong C and D. Yun, guys. Anyway, the answer is parents C and D. So, look for yourself. Okay? Sinong parents ang mas maraming kamatch with the soldier? And next, was the suspect at the crime scene? Yan. So, what was at the crime scene lang ha. So, hindi ibig sabihin siya yung pumatay. Okay? So, this is the suspect profile. Ito yung STR results niya. Blood sample from the crime scene. Almost the same. Yan. So, yes, the suspect was in the crime scene. So, going back, guys, sa case ni Linda Mann and Don Ashworth, hindi ba kanina that may 17-year-old na si Buckland was the prime suspect. However, through DNA fingerprinting, he was the first person to have his innocence established. Okay? So, itong si Richard Buckland, guys, siya yung prime suspect. But through DNA fingerprinting, hindi niya kamatch yung mga semen sa genitals nila, Linda and Lon. Okay, yan. So, Leicestershire Police undertook an investigation in which they collected 5,500 local men were asked to volunteer blood and saliva samples. So, they were looking for that man. Grabe, 5,000 na lalaki ang ginawa nila. This took 6 months and no matches were found after 5,000 plus samples. Okay? So, ang prime murderer, guys, is si Colin Pitchfork, okay? He is a double child murderer and rapist. And so he was the first person to be convicted of rape and murder because of DNA profiling after he murdered 2 girls in Leicestershire Village. Yan. So sabi, paano siya nahuli? So in 1987, so after a year, guys, na namatay si Don, one of the Pitchfork colleagues at the bakery, Ian Kelly. So guys, itong si Colin Pitchfork is a baker. He's a cake designer, okay? He revealed to his fellow workers in a pub, in a Leicester pub called the Clarendon. Yan. So, nagiinuman siguro, he had taken the blood test while masquerading as Pitchfork. Okay, si Ian Kelly, guys, so, minarites niya sa mga colleagues niya na sabi niya, ako yung nagbigay ng dugo at laway in behalf of this guy. Okay? So, imbes na yung dugo at laway ni Colin yung mabigay sa police, yung dugo at laway ni Ian ang pumalit sa in behalf of this guy. So, Pitchfork had told Kelly that he wanted to avoid. So, ba't sinabihan niya si Ian Kelly na ikaw na lang ang magbigay, ang magpa-swab at saka magbigay ng dugo. Want to avoid being harassed by the police because of his prior convictions of indecent exposure. Yan. So talagang guys, may kaso na tong si Colin Pitchfork na pinapakita yung genitals niya in public, ganyan. Talagang hindi niya daw talaga tinitigilan yung mga babae na ka-work niya. So sabi, a woman who overheard the conversation reported to the police. Yan. So may marites, guys, na nakikinig ng usapan ni Ian Kelly na siya daw, instead of Colin, siya daw ang nagbigay ng dugo at laway. Yan. So may nagmarites, sinumbong ng isang nakarinig sa pulisya at kumuha nga sila ng laway at dugo kay Colin Pitchfork. Ayan. And he was the murderer. Yan. So his DNA matches the sperm that are found on our victims, Linda and Don. Okay, so that's just an overview, guys, on the application of molecular biology. Guys, I'll see you again. Bye-bye. Salamat. Molecular bio ends here.